Hello everyone, in this video we are going to learn about increasing and decreasing functions. Let us first learn a little bit of theory and then we are going to solve the problem given above. And this is going to be helpful for everyone who has this in their syllabus and also JEE and ISICM aspirants and also board aspirants as well. And also someone who is in college who might be struggling with these topics. So here's a detailed breakdown of how increasing and decreasing functions should be dealt, how problems should be solved, and at the end I will show you how to generate infinitely many tests for them as per your pattern using AI and never run out of credits using my app. Okay, first of all, for increasing function, I'm going to denote it like this using an upper arrow, which would just simply denote that it is increasing, and a down arrow to denote that it is a decreasing function. Now, in simple words, if you were to draw or plot a curve, and the curve looked something like this, where gradually, as you go along the x axis towards the positive direction, the y value keeps increasing, if you can see, right? The y value keeps increasing. If this happens, and if this happens in, let's say, and between the interval a to b, where x is a here and x is b here, then we say that let the curve of the function be called y equals to fx. This is the equation. We say that f of x is increasing, f of x is increasing in a comma b, meaning that inside the interval a comma b, what happens is as you go more towards b, the value of the function, that is the output of the function, keeps increasing. A good example would be f of x equals to x square. And let's say we take the interval 1 to 3. Now, what happens here? You can see that f of 1 is 1, right? And if you go on, f of 2 would be 4, and f of 3 would be 9. It is not hard to contemplate that obviously values between f of 1 and f of 2, whatever you choose, let's say 1.5 or something. So if you were to choose f of 1.5, this would simply give you what? 2.25. And that is greater than 1, but that is also less than 4, right? In simple words, an increasing function is such that if you were to take two values, let's say you take two values x and y from inside its domain. Domain means the values which are permissible to be treated as inputs to the function, right? Those are called domain. Those are the set of those values is called the domain of the function, right? Now, if we were to simply take two values from the domain x and y, then we would see that for x greater than y, we will have f of x greater than f of y, correct? And for x less than y, we would have f of x less than f of y. So this simply means that if the x coordinate, if the value of the input is bigger than some other input, then the output of that input is also going to be bigger. Similarly, if the input is lesser, the output is going to be lesser. This is how increasing functions work, correct? Now, if we turn to the decreasing functions, we obviously would see a complete reversal in the process here. So for a decreasing function, we have for all x and y belongs to D, and let's say the function is decreasing over the interval D, is what I'm saying. So if the function is decreasing in D, which D is a set, obviously, then what happens is if x greater than y, then we simply have f of x less than f of y. Do you see? So as you go further towards the x-axis and as you increase the inputs, the outputs get smaller. And similarly, if x is less than y, then we would simply have f of x greater than f of y. A good example of this function would be f of x is equal to e to the power minus x. Okay. Now, these are increasing and decreasing functions, and the best way to find them is this. So, step one, you find the derivative. So usually, if the function is differentiable, of course, you are going to find f dash of x. And step two is nothing but check if f dash of x is greater than 0 or f dash of x is less than 0 inside Let's say some concerned interval is there, a comma b. We are going to check inside a comma b if f dash x is 0 or f dash x is less than 0. Okay. And step 3 is the conclusion where you simply say it is increasing or decreasing. So f dash x greater than 0 would simply mean that it is increasing, but the function is increasing only in the interval x belongs to a comma b. It's not necessary for it to exist at the endpoints as well. And if f dash x is less than 0, we simply say this is a decreasing function for x belongs to a comma b. Correct? So this is the simple procedure. Now, algebraically, you would understand that since f dash x is greater than 0, this also means that for increasing functions, we would also have limit h tends to 0, f of x plus h minus f of x divided by h greater than 0, right? And for decreasing functions, we would have the same limit because this is the definition of f dash x, limit h tends to 0, f of x plus h minus f of x by h less than 0. Okay. This is the same thing as we just learned about x greater than y, f of x less than f of y, stuff like that, because h is positive and we are saying that if it's an increasing function, then obviously this limit is positive. H is positive, which means the numerator must be positive, and therefore f of x plus h must be greater than f of x. And you can clearly see h is arbitrarily small, and obviously x plus h would be greater than x. And that also implies that f of x plus h is greater than f of x since the entire limit is positive. Now, this should clear up. This is a very basic chapter, but the problems only revolve around solving equations of different orders using some kind of partial fractions, using the wavy curve method, using finding out intervals in which a function increases or decreases, proving some properties regarding the differential equations and differentiation usually. Sometimes second order derivatives are also included. Now, let us come back to the actual problem that we started with. It was let h of x equals to f of x minus f of x whole square plus f of x whole cube for all x belongs to R. And then we need to prove that h of x is increasing if f of x is. Let's just write down the problem here that, okay, we are given h of x equals to f of x minus f of x whole squared plus f of x whole cubed. Correct? Now, we want to prove that h of x is increasing if f of x is. Okay, that's good. Let's see, h prime of x is equals to f dash of x minus 2f of x, f dash of x plus 3f square of x into f dash of x. Now we clearly understand from this that we can take f dash of x as a common term from the three terms we got, and inside we get 1 minus 2f of x plus 3f square of x. Now we understood the procedure here, that step 1, step 2, step 3, and I've literally I have taken a good problem for a general f of x, right? Why did I do that? Because I wanted to demonstrate that no matter how hard the problem is, we're going to follow the same procedure. Now, step 1 is complete. Step 2, we have to check. Now, of course, we were given x belongs to real, so we understand that a and b are nothing but minus infinity and plus infinity here, and we need to check if f dash x is positive or negative. But right now we are only investigating and we are not proving it is increasing or decreasing. So, okay, we first need to tackle this thing. So let's write it down, 3f square of x or f of x whole square, whichever way you want to write that, minus 2 of x plus 1. Now, let's take 3 common and we get f of x whole squared minus 2 times 1 by 3 times f of x plus 1 by 3. Okay. So I am trying to complete the square here, and let's do that 3 times. And f of x whole square minus 2 into f of x multiplied by 1 by 3. We have a 1 by 9 and we have a minus 1 by 9 as well. Now, inside we get 3 times, and this becomes f of x minus of 1 by 3 whole square. If you see here, a square minus 2ab plus b square. And this one is 3 by 9 minus 1 by 9, which is nothing but 2 by 9. And if you were to expand this out, you would simply get 3 of f of x minus 1 by 3 whole squared plus 2 by 3. Now, as you all would know, this is always positive because a perfect square is always positive, which means this entire thing is always greater than or equal to 2 by 3, which is greater than 0. So it's a positive term, right? Now, if you come back, we would simply write h prime of x, which we just found, as f prime of x multiplied by some lambda, where lambda is nothing but this expression. Okay, this expression is our lambda. And we found out that lambda is always positive, correct? Now, that means the sign of h prime of x, which means the if it is positive or if it is negative, depends entirely on the sign of f dash x and not on lambda because lambda is always positive. Now, if f of x is increasing, so if f of x is increasing, that would mean that f dash of x greater than 0, and that would mean that lambda f dash of x would also be greater than 0 since lambda is greater than 0, and that would mean that h prime of x is greater than 0, implying that h of x is increasing. So h of x is increasing only when f of x is increasing, and in a similar way, you can also show that if f of x is a decreasing function, then h of x is also decreasing. There could be many more examples. So I would just let you solve on your own. You can download the app from the comment section and you can see a little glimpse of how to generate tests here. That should be all. Thank you for watching and let me know in the comment section if you have any doubts.